So.
Okay. Don't know exactly what I expected, but it probably wasn't this. But that's. Can you
Probably
imagine if
some.
you decide to learn Go, and you sit down and you go, right, I'm going to write a program. Okay, I'll run it. Here's what I see. you know, that's an unpleasant UX, isn't it? This is a bit off-putting for newcomers. I really think there should be a sort of an easygoing mode that you can set where it just says, hey, it looks like you tried to dereference some pointer that was nil. Do you want to rethink
Yes.
that? you know, you don't want to see a stack trace and the word panic, do you? It's quite unsettling. So, but what I teach people to do is exactly what I do myself. Is I say, first of all, don't panic. Just read through the stack trace, find the file and line where it's happening. So of course what we're seeing is the stack trace is in reverse order in a function first. So the very first, the place where that panic is actually thrown is in testing.go line 1143. But that's not us, that's just the testing machinery. And that was called by the next thing in the stack trace, testing.go 1146, still not us. Who called that? Well, it was panic.go, line 965, still in the standard library, and we're working our way down, aren't we? So who called panic? Well, it was indirectly func.fprintf. Apparently we're trying to print something and we panicked. So where was that? That was in print.go. Where was that called from? Well, that's actually in our code now, isn't it? That's lambda.go line 45. So we can go there.
Let's go. Line 45.
And we can say this may not actually be where the problem, but it's where the problem manifests. What are we doing? We're printing safe landing. We're trying to print the safe landing message, and we're getting invalid memory address or nil pointer dereference. Well, we're not referencing any memory, so there must be a pointer involved. G-state velocity is not a pointer. G output is also not a pointer, but it's an interface type, isn't it? It's IO writer. So clearly that must be nil. That's the only thing it can be, isn't it?
Yeah.
So why is g.output nil? Well, maybe we never set it to anything.
Yes.
If we don't explicitly call with output, we just don't ever set it, do we?
Yes, so we don't have actually default settings for this.
But that would be very easy to do. And the constructor would be the place to do it, wouldn't it? We are constructing a game literal by means of a state literal, and we can now add values for input and output.
Yeah, so game we have state, and then we have output input.
And it's completely reasonable to default to standard out and standard in, isn't it?
I don't know if we need input. No, we need input, yeah.
Only for the tests, really.
Yeah, yeah.
But that's okay. Tests are important. So, all right, well, I feel like we shouldn't get this panic, should we? We might get a different panic.
Okay, so let's try to run again.
Oh, that's... Well, it's not panicking. That's great. It's not passing, but we knew it wouldn't. We have some...
So we know that code compiles. That's the most important.
Yeah, exactly. And test new game is failing because we wanted the exact game value, which is now different because we've set output and input. So we could just want those, couldn't we? That's easy. That's just a refactoring bug.
Okay, so first error we are getting here. Lander test 26. So let's go here.
But I feel like we should use comp equal and comp diff here, shouldn't we? Because it's quite hard to read this failure.
Yes, yes.
And that's one reason I always want to see my tests fail.
Mm-hmm.
Even if by complete coincidence, I happen to get the code right first try. That does happen sometimes, not always. But if that's the case, then what I need to do is deliberately break it so that I can see what the failure looks like, because the failure is the whole reason I'm writing the test. Its job is precisely to print out this kind of information, isn't it? And it turns out this isn't a very useful format. It's hard for me to see what's different between these two structs. So instead of just saying want x got y, I can just give the comp.diff of those two structs, and I'll see a nice visual diff. And I can also use comp.equal. And I was delighted to see when I was reading Jon Bodner's excellent Learning Go book this week. He says exactly the same thing. He recommends using the CMP library for this stuff, which is great.
Transmission something.
That's right, and it's not error F because we're not supplying any F.
T error. Okay. CMP diff. Okay.
And we want comp diff, not comp equal, don't we?
Oh yeah.
Perfect. Yeah, so let's just run that again, and we should see a more helpful failure, shouldn't we? Still the same failure, but just formatted more nicely.
So this. Wow.
That's disappointing, but okay. It's panicking again, but now it's comp.equal that's panicking because it's saying cannot handle unexported field. Yeah.
Yes.
.output, and that's fair enough because it's the same sort of thing that bites people with JSON marshalling and unmarshalling, isn't it? In Go, if you have a struct with unexported fields, they're just ignored. And the reason is, if you wanted to write JSON unmarshal, you could write it. You could parse that JSON somehow and just try to set the corresponding fields on the struct that gets passed to you. But if they're unexported, well, you can't do that, can you? So guess what? The JSON library can't do it either. It doesn't have special VIP privileges just because it's in the standard library, and GoCMP isn't. So same thing applies there. So we can do one of two things here, couldn't we, at least? We could export those fields. That's all right. Or we could tell comp equal, hey, ignore unexported fields.
I will go with the second option.
Yeah, that's
not
something.
Not to adjust actually our code to test, but other way around.
Yeah, that's something we can do. What we can do is we can pass an extra argument to cmp.equal. Right now we pass it want and got, and we can pass it a third thing, which is we can pass it an option saying ignore unexported fields.
Okay, so CMP. I remember from your book, just index it in my memory, that you provide this solution.
Right.
One of the
well, one reason for writing it in the book is so I don't have to remember it, because I don't remember it.
But CMP ignore, right?
Yeah, I do remember that it's actually in a separate package. It's in a CMP opts package. So it's something like CMP opts dot
options
ignore unexported fields. Yeah, the package name is actually CMP opts, all one word.
Ops,
that's right. Okay, that's helpful. Ignore unexported. Yeah, that sounds perfect.
Yeah, perfect.
Great. And the slight wrinkle with this is we can't just say ignore unexported. We have to say ignore unexported fields of this struct that I'm going to send you. So we have to pass it a value of that struct to say it's this struct I'm talking about.
So it will be our got, yeah?
Yeah, in fact, any value would do. And we have got, so we can pass it that. So I think this is enough. Let's try.
And again, I will clear. Missing goes some entry for module. Okay, this is package related.
That's slightly surprising. Will go.mod tidy fix this? If not, I think we're in trouble. Okay, good.
Here we go. Yeah.
All right, that's fine. So yeah, I was slightly horrified by this when I was writing the book because I was really enthusiastic to recommend GoCMP to everybody because it's great. And I proudly presented it, you know, said write this test and then call cmp.equal and everything will be great. And then when I did the sort of last minute check, you know, right before I shipped the book, just rerun all the examples to make sure they pass. And I got that horrendous panic. So, you know, because I'd unexported one of my fields and not realised. So I thought, oh, you know, this is awful because imagine if you're, you know, a Go beginner and you're reading this book thinking this is great. It's all going so well. And then you hit that and you're like, oh my God. So I was thankfully able to tell people what to do, which is exactly what you just did. Ignore unexported. Marvellous. So test soft landing and hard landing are both failing because they get no message at all. That feels like it must be a minor refactoring bug, doesn't it?
Mm-hmm.
And then the last one is, I think that's absolutely correct, and we just need to copy and paste our test expectation. So
yeah,
let's try and fix, what's this, lander test 105, wanted, safe landing, got nothing. What's going wrong here? Are we not?
Soft landing display results. Displayed soft landing.
Are we
Displayed
not?
results success. Oh, hold on. Buffer I'm passing with input.
Oh, I think that should be with output, shouldn't it?
Yeah.
That would explain the failure.
Display. Oh yeah. With output, and we are passing our buffer.
Yeah, and that's probably a signal to us that we actually should have named that. Instead of buff, we should have named it output, shouldn't we? Because then we would have found ourselves writing with input, output. And we'd know that was wrong right away. Or with output, input, either way.
And here as well.
Yeah, same thing.
The same error.
Yeah, and with that done, we should be down to our last failure. And
our last failure, land safety. Is it what lander test played the game?
Yeah, and that's okay because we said that we're not going to bother to write our want. We'll just have the game printed out for us, and it has, and that looks right to me. What do you think? Starts with the welcome message, land safely, and then gives you the first state vector line, prompts you for the thrust setting, and then it says landed too hard.
Oh yes, this is output from, yeah.
Which is correct, isn't it? That's all correct. So yeah. that literal string is what we should want, and we'll get it. This is a nice tip too, isn't it? Don't bother to write your expectations, just see what
observe.
Yeah, see what you actually get. If it looks right by eye, it probably is right.
Okay, so let's try.
I think we should be there.
Bingo.
Marvelous. Now we should, this is a great point to start wrapping up because you've definitely gone above and beyond the call of duty and we really appreciate it. But the very final thing we should do...
Really enjoyable, yeah.
We should just complete that refactoring, shouldn't we? And just call, from main, we should call play game, and that's it. That's all there is. And then we should play it. We don't need to pass anything. because of our wonderful functional options, the defaults will be correct. So that's it. And that really is the kind of main.go that I want to write.
Yes, yes.
An almost completely useless one.
Yes, but I started liking this simplicity of main some time ago. Yeah.
Wonderful. Let's try it, shall we? I feel it should work.
Okay. Let's save this and let's run it. Go run. Make it a little bit. Settings.
All right so far. Wow.
Boom.
Brilliant. Yep. Happy with that. Very nice.
Second try. Very nice. Yeah.
So that's definitely a commit point, isn't it?
Yeah.
So that's really nice, and I think, you know, one of the things I remember when I started learning Go was looking at videos on YouTube and things, and some of the best ones I saw were Francesc Campoy's Just For Func series. You might have seen this yourself. What he does there is basically, in most of them, he just sort of says, you know, let's write some program, you know, a game, let's say. There's one where he writes a Flappy Bird game. And he just kind of sits down and starts cranking it out. You know, I was quite surprised by this. I expected him to sort of say, well, let's draw out what the game's going to look like, you know, design the architecture. I wasn't expecting a UML diagram, but you know what I mean? I was expecting some thinking up front. But he'd just charge in and start writing main.go. You know, and he'd get it wrong. You know, it wouldn't work, and he'd see what was wrong and fix it. And I can't really explain why this is, but I just felt energized by that. You know, I thought, wow, you know, he really knows what he's doing, and he's just kind of typing stuff, getting it wrong, fixing it. That's what I do. You know?
And it really shows that programming is not magic. It's basically everyone works almost the same. There is no person that will sit down and just type the program and everything works first time, especially some complicated one.
That's exactly right, and I think that's a lovely way to put it. It's not magic, but it can seem like magic if you're new to it, you know, and especially if you don't see these steps. You know, if you only start the video once you've got a really beautiful architecture, and I think that's a shame, because you miss seeing this stuff. And I hope people watching this will sort of feel a little bit the same as me, thinking, you know, these guys are pretty experienced, you know, not masters by any means, but we know what we're doing, and this is exactly what we do. Is we just sort of we play around, we try stuff, think about it, rethink it, you know, refactor everything, and we actually get something pretty good. So that's great. Yes, we did play a game, didn't we? And we can commit there. So that's wonderful. So it only really remains for me to thank you again for donating your time to this. It's been really fun for me.
For me as well. Really fun.
We went on quite a while, longer than I planned, but I was actually having so much fun that why stop? You know.
That was a good decision.
Yeah. Okay. So thanks very much, and for everybody at home, I will see you in the next episode.
Thank you. Bye.
Bye for now.